Hey classes, welcome back. I am at the back of the room right now at the good old chalkboard. What these videos lack in production value, hopefully they make up for in content, we'll find out. But if you look at this board, we started the day with a little bit of current events. We saw the Artemis launch, which they're hoping to do tomorrow. By the time you watch this, maybe we will have a rocket on the way to the moon. This particular one is unpersoned, but we are hoping to return to the moon. We first went to the moon, of course, in 1969. When I was a little kid, I remember very clearly toddling out to the front room with my stuffed bear, watching the news broadcast of people walking on the moon. That was 1972, and we have yet to return to the moon. As a matter of fact, when we're talking about sending people to space, we generally are staying in low Earth orbit, 200 miles or so. We haven't sent a person 250,000 miles since 1972, so that's a big deal. Also, check out our Celsius to Fahrenheit conversions. We had the students up and out of their seats today, checking out the temperature on the wall thermometer, and a little bit of practice, just a tiny bit, going through what we saw in some earlier notes. In science, you want to start off with the formula. We had our formula on the notes, which you'll see in a second. Step one is always to write your formula. Your formula is like your map, shows you where you're going. Then step two, you pop in the stuff that you know. In this case, we wanted to go from temperature Fahrenheit we want to go from temperature Celsius to temperature Fahrenheit. We popped in our Celsius degrees, which on our thermometer over here said 21 degrees. We pop that in and just a little bit of math, and we'll get, again, if you need some help with the math, if you need some help with working with rational numbers, come on by before school, at lunchtime. My prep period is 5th period, or after school. I'm happy to give any math help, in addition to the help that you get maybe in tutoring or with the math teachers across the hall. Anyway, you're popping in what you know to the formula, and then it's just a little bit of math after that. Do check out this symbol if you're not familiar with it. This means about or approximately equal to. If you run through this math right here, the actual answer is like 69.8 degrees, but nobody ever would say, unless you're Mr. Spock, you're not going to give the temperature as, well, it's 69.8 degrees in here, Captain. No, you're going to say, approximately or about. Again, over here, when we look at conversion factors, a conversion factor in your math books, these math books that we're using here on campus, they refer to as a big one. It's literally what they call it in the math book. They show a giant one superimposed over the fraction, and essentially it simply means that what you have on the top, the numerator, is the same as what you have in the denominator. Same thing here. 1 kilometer is 0.62 of a mile. 1 mile is 1.61 of a kilometer. You use those to convert when you're going, for example, from miles up here to kilometers down here. And again, notice the about or approximate equal sign. It's not exactly 400,000 kilometers, but we're using an approximation. In science class, we want to be good about when we use approximations, and there's a lot of times, it's like cooking. You want to go through the times that you're using an approximate value and a real exact number. Let me get this really very quickly up here. If you look at our brain pop, we were going through the types of energy. All of today was really kind of designed to lay the groundwork for next week. Next week, we're going to be going into a little bit, it's like a mini crash course on physics. And our crash course on physics is designed to get us ready for the movie, The Martian, one of my favorites that we use in class. We're not going too deeply into it, but we certainly are going through 1 or 2 formulas: speed, distance, time, and Newton's laws, absolutely, and a little bit more on conversion factors. We're going to have math practice and conversion factors throughout the year. Moving on, we had the types of energy right here. In particular, we talked, for example, about the chemical energy sitting in the tanks at this very moment of the rocket that will carry the Artemis missions to the moon. Potential energy right here in terms of those chemical bonds we're going to learn all about. Atoms and molecules and how you can store energy in those chemical bonds. The thing we focused on in class today too was the difference between position or potential energy and kinetic energy, the energy of movement. Here were those formulas for converting between temperature Celsius or temperature Fahrenheit. If you have one and you need to get the other, you use those. Okay, note the 7 iron yet again in class. And as I switch the boards, I'll go fairly quickly here. I'll fly through it. I'll put these out there online as well. Tiger Woods, hopefully he won't mind me using his likeness up there. And of course he's right-handed. Don't know why anyone would play this game right-handed, to be honest with you. But when you're looking at potential energy, you're looking at energy of position. In the case of any sport, I'm using a sport today because we were checking out a little bit of the Mythbusters. We saw a little bit with football, a little bit with baseball. I was trying to use the example of any sport where you use, say, a bat, or like if you're talking lacrosse, baseball, golf is the one I used up here. When he's getting ready to hit, he's in that position that he's getting ready to hit, he's got what we call potential energy. You can feel this if you hold a bat. You feel like a spring that's wound, ready to go. And then once the movement starts, you're going into kinetic energy. Ideally, that kinetic energy will be transferred to that ball, and most of that kinetic energy of the ball will, of course, send it to the target. An important concept that we're going to be going through next week is the conservation of energy and the conservation of matter. How energy and matter both, when we say conserved, we mean they never really go away. They just change forms between types of energy. It's very, very, very important concept in physics about how energy does not simply go away. It has to go somewhere. In the case of the golfer, they're obviously transferring it to the ball. And then going back to 1972, and probably after I watched the moon landing, I flipped right to the cartoons. One of the classic examples of potential energy, I think I've seen it in every physics book that I've ever taught with or ever read as a student, is they always show a boulder way high up. It's got the potential to do something. In other words, at any moment it could fall. Once that boulder starts falling, you've got kinetic energy, energy of movement. If you study kinesiology, you're studying movement, right? Our challenge for the students while we watched it today, and again, I'll put these answers out there next week especially, but on the line this weekend if I get a chance, certainly on Tuesday in class, we'll go through the independent, the dependent, and the control variables. With the Helium Football, an excellent experiment that they did where they launched some footballs at Moffett Field inside the big hangar down there. The independent variable, of course, again, was the gas inside the football. They only used two. They used regular air, if you will, 80% nitrogen, 78% nitrogen, and carbon dioxide, oxygen, all the things that are in the atmosphere. And then they used pure helium. Again, that was their independent variable. The dependent variable was how far did the ball land after it was launched. And all the controls. They controlled weather. They had Soderbergh, a kicker from San Francisco City College, doing the kicking. They took him out of the equation. They used a mechanical launcher. They controlled the weather by going indoors at Moffett Field. This is back when they had that covered hangar down there. They controlled launch angle. They controlled launch speed. And all the footballs were pumped up to 13 PSI. That's a big deal if you're trying to control as many variables as you can. Turned out, they did a little math at the end, which is why I'm showing you so much math in this class. They talked to a statistician, and there was no statistically significant difference between a helium-filled football and one filled with regular air, if you will. The challenge for the students today, we just started it today, and we'll continue this again into Tuesday, which is why I said I'll put up the answers there on Tuesday. The baseball myths. I'm, again, just picking out a little bit from one of the very good Mythbusters. It's the last 15 minutes of class or so that we do that. But the baseball myths, in this case, are two of them. One, they're talking about a corked bat. That will lead us to talk about Newton's laws, which we need to learn next week, or at least start to learn next week. And two, this is the one in particular we want to list the variables on. Humid baseballs versus dry baseballs. They talk about the dry baseballs that they use in Colorado, and they start putting into humidors to keep them a little wetter in the hopes of maybe bringing down the home runs that are hit up at that Mile High Stadium. Coors Field, I think it's still called. And if you look at the stadium up there, not only is the generally drier up there, but you're talking about slightly thinner air. So that'll lead us into our atmosphere unit, which comes a week later. And so your baseball variables right there, you've got your independent variable, the amount of humidity that the ball is stored in, the dependent variable, how far is that ball going to travel when hit, and then all the controls that we'll be looking for next week, which will be, as you could probably guess, the swing speed of the bat, the angle at which it is hit, and the weather conditions as well. So with that being said, have yourself a great 3-day weekend. See you on Tuesday here in class, and I hope that the math that we're doing up here is starting to click with the math that you're doing across the hall. Finally, last little thing, don't want to forget, check out the moon. Your moon observation is ongoing for about 2 or 3 weeks, and we want to check out that beautiful crescent moon and see how it changes over the next couple of nights. Have a great weekend, and I will see you both online and here in the classroom. Bye-bye.